What's going on, guys? Hey, listen, we've gotten through most of the work for the first test. So I've got a review sheet for you today. I'm about to go through all the solutions on this review sheet with you. It may or may not take more than 50 minutes. I have no idea. Here's my advice. Please, for your sake, go and do the review sheet. Just do everything you possibly can. Hopefully you'll have great success with it. In fact, you might even do it without your notes just to really kind of see what you do or don't know. And then check the key. I've got the key posted. Go ahead and check that key. If you got it right, then fast forward through all the stuff on the video that you got right. But I am going to go through every problem as quickly as I can, but trying to emphasize things that maybe people do wrong, things that I've done in the past, maybe that you've missed. And hopefully after going through this, you'll be in pretty good shape. So anyway, good luck with it. I hope you guys are doing well and are not too bored. I've heard from a few of you. It's technically not even April 6th right now. It's, I think it's, I don't know, March 31st for me. I've kind of lost track of time, but I'm trying to get a little ahead. So anyway, hopefully you guys are good and we'll do well on this. But again, try to do it on your own. If all you do is watch the video, you're going to learn a little bit, but it won't be the same as if you had actually tried it yourself. And then tomorrow, we'll have the test ready for you and you can check back and see how we'll handle that. All right, guys, good luck. All right, guys, so here's your review for sections 12.1 through 12.5. Hopefully this stuff doesn't look real new to you and you feel pretty comfortable with it. But if not, try to learn from all this. Again, you're going to need a calculator for this test. For sure, at least a scientific calculator. And I'll try to do problems with Inspire kind of thinking and with kind of scientific calculator thinking. So you'll, depending on what you have, you'll feel pretty comfortable. Okay, first thing. What quadrant is the following angle's terminal side located if the angle's in standard position? So what does standard position mean? Remember, standard position was if one of the sides is pointing at like 0 degrees, then the other side would be pointing at this particular, or one of these angles. So negative 115. Well, we know positive opens that way, negative would be that way. So negative 90 would be straight down, so negative 115 would be, so if this was pointing at 0 degrees, the terminal side, then 90 would be straight down. A little bit past 90 would be something like, well, that would be a negative, if that was an arrow right there, opening to that. That angle right there would be a negative 115. So if you think about that, that would have to be in the first, second, third quadrant, or you could just write the number 3RD or third, whatever. 265. Okay, 265. Again, if the initial side, I'm sorry, I keep saying terminal. If the initial side is at 0. If the initial side is at 0 and I'm moving to 265, positive means you open counterclockwise. So 90, 180, 270 would be straight down. 265 must be a little bit less than straight down. So if you were drawing the X and Y axis in there, again, that would be third quadrant. Okay, negative 179. Well, there's, again, initial side at 0, and my if I had that on an X and Y axis right here, negative 179, I've got to go clockwise, 90, 180, so negative 179 is just shy of that. So again, third quadrant. And then 1238, well, that's way beyond 360, so I'm just going to take a calculator out. It doesn't matter which one it is, and I'm going to say, all right, 1238, and I'm going to subtract a bunch of 360s, and I'm going to keep doing that until I get an angle between 0 and 360. So I know you probably can't see that right there, but I subtracted 360 3 times, and I got 158 degrees. So if that is in the same location as 158 degrees, they're not the same angle because that had a bunch of rotations, but it's in the same location. So in standard position, where would 158 degrees be? Well, again, if the initial side is at 0, 158 would be 90, 180 is there, so it's a shy of 180, maybe right in here, that angle. So that would be in the second quadrant. All right? And then this says express in decimal degrees to the nearest hundredth of a degree. What that is? Well, I'm giving it to you in degrees, minutes, seconds. So again, you got to know how to use your calculator. It just depends on what calculator you have. I know a lot of you will probably have a scientific. All right, so remember what we said, you could take this and type in, if this is a Texas Instruments TI-30X2S, which is a pretty decent scientific calculator. So right here, if I typed in 112 and then go to my degrees button and choose degrees, it says, all right, that's 112 degrees. And then 35, go back to that degrees, minutes, seconds button, go over to degrees, enter that, and then 27, go back to that button, over, enter that, and when you hit enter, it gives you 112.59 if I was rounding to the hundredths. So 112.59 degrees. All right, and then if I have a decimal, all right, then you would just enter that as 29.48. And then you go back to that button, but this time you're gonna have to go way to the right to DMS, hit enter on that, and it changes to 29, 28, 48. So that's 29 degrees, 28 minutes, and 48 seconds. And if it was a decimal, it says to the nearest second. So I would just, actually that's rounding up to the nearest second. But if it did say round, then just write 48.3 seconds. This one didn't have a decimal. All right, now with an Inspire, it's actually a little harder to use, I think. So if I want to enter that, if you do have an Inspire, I'm going to zoom in a little bit for you. Okay, so if I do have an Inspire, I would enter 112, and then I can go to my pi button on the bottom left and enter a degree. I could do that and try to enter it that way, but there's actually a button on your book button. Remember the book button? The book button is right there to the left of it. If you click enter on that, you can see right there, there's a button. It's to the right of the absolute value. If you hit enter on that, it gives you a place where you can go 112, go over 35, go over 27. It has all the bubbles and the dashes already, apostrophes already in there, and you can just hit enter, and there's your 112.59. And if you want to do it this way with a, if you have the decimal degree already and you're trying to go to degrees, minutes, seconds, then just enter the 29. Sorry, y'all can't see that now. The 29.48, and then hit the right side of the book button. And on number 1, you have all these operations programmed in from A to Z. Just hit the letter D. Like watch, I'm gonna hit the letter B and it jumps to B's, M and it jumps to M's, F and it jumps to F's. Well, I want DMS for degrees, minutes, seconds. So I'm gonna hit D and then scroll down. And more than likely, if you have an Inspire, it's already sitting on DMS already because we did that last, and I doubt you've been using this in weird ways. So hitting it there, it says, oh, you want to change it to DMS. Just hit enter again, and there you go, 29, 28, 48, just like before. All right, so let me zoom back out a little bit. You're not going to see a whole lot of that degrees, minutes, seconds stuff, but and I used to make my kids do it all manually, but with the calculator now, it's pretty obsolete doing all that stuff. So make sure you know the 6 trig functions. Remember, sine is not just opposite over hypotenuse. I want you to do that here. So you can say opposite over hypotenuse. That's fine. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And if you didn't know it, tangent's also sine over cosine. If I put that sine over that cosine, look, the h's cancel and I get O over A. All right, cotangent is the reciprocal of tangent, so it is A over O. And then secant is the reciprocal of cosine, so it's ha, H over A, cosecant, H over O. All right, and with sine, I also want you to know the trig function sine through cosecant in terms of x, y, and r. Now, it's important that you know that we're thinking about the unit circle, right? So, or anything in standard position. X is that movement, Y would be that movement, R would be the hypotenuse. Okay, so thinking like that, sine is the opposite over hypotenuse, it's the Y over the R, cosine adjacent over the R, X over the R, and then tangent is Y over X. We're talking about that angle, right? Not this one, but that one, Y over X. And by the way, we are always talking about that angle when we're dealing with X, Y, and R. We never are talking about this angle if we're putting it on an XY coordinate plane. Cotangent, the reciprocal of tangent. Secant, the reciprocal of cosine. Cosecant, the reciprocal of sine. So hopefully we're pretty good on that. And remember, if I'm using the unit circle, what's R always going to be? If it is a unit circle value, it's 1. And if it's 1, I can just say Y, X, 1 over X, 1 over Y. If we're using unit circle. Now, if it's just a random triangle that's drawn, and if the radius is not 1, then you got to make sure you put that radius value in there. All right, a couple little things. I think I mentioned this just a second ago. Sine over cosine is tangent. So if I ever have sine over cosine, I don't have to waste time by saying O over H divided by A over H, and then multiplying by reciprocal, cancel everything, and going, oh, O over A, that's tangent. I ought to just remember that this is the tangent of theta. And then cosine over sine. Well, if sine over cosine is tangent of theta, then cosine theta over sine theta should be cotangent of theta, because those are reciprocals and so are these. All right, what's the reciprocal of a cosine? Secant. What's the reciprocal of a cotangent? Tangent. What's the reciprocal of a secant? Well, cosine. And what's the reciprocal of a cosecant? Sine. All right, and that's important for some of the solving that we do when you don't have an inspire. All right, get some of this junk out of the way here. All right, so scrolling up a little bit, 7 says simplify the trig expression. Now these are things that you're going to be able to need to do without your calculator. With your calculator, a lot of times you get weird decimals, and I'm going to want exact values like root 3 over 2 or square root of 2 over 2. So make sure you know how to use unit circle. So at 330, I know you're not staring at a unit circle right now, but if you were, 330 is that angle that's really close to 360 right here. Not the middle one, not the 300, but right there. Okay, so what would it take to get right there? That's over a lot, down a little. So over square root of 3 over 2, down a half. And since sine of an angle is the y value when I'm doing unit circle values, down a little would be negative 1/2. So hopefully you can visualize that in your head and not even need to draw this. But I'm going to kind of help you right here. All right, 7 pi over 4, where is that? Well, hopefully you know that, remember our little tricks? If it's in the 4th quadrant, you double the bottom minus 1. So this must be in the 4th quadrant. So I'm thinking, all right, what would 7 pi over 4? Well, remember how when you're labeling these, it goes 2, 3, 4, 6. 2, 3, 4, 6, the denominators? Well, 2, 3, 4, that's 4 must be the middle one. So that's the one that has the same movement this way and then that way. Well, cotangent puts x over y. So what's x over y on this special triangle? If those are the same, then they're going to cancel, except for maybe the signs, the S-I-G-N's, not the S-I-N-E's. So this was over square root of 2 over 2. So the hard way to do it would be to go, I'm going to the right root 2 over 2, and then down root 2 over 2 to get to right here. Well, that's going to cancel everything except that negative 1 and that positive 1, so negative 1. And then finally, secant, where's pi over 3? Well, where do you only have 1s with the pi? That's first quadrant. So that would look something like this if you're labeling it 2, 3, 4, 6. So 3, those are the tall reference angles, right? So to get to there, I would go over a little, up a lot. Well, what is secant? Secant is a reciprocal of a cosine, right? And cosine is x when you're dealing with unit circle. You don't even have to do x over r because the r is 1. So the x would be a half, right, over a little. So secant says flip that 1/2, must be a 2. Now the hard way is to go, it's 1 over a half. And to divide by half, you multiply by 2. But I hope you'll just go, wait a minute. If the x movement is a half, the y movement square root of 3 over 2, all I need is to flip the x. Flipping a 1/2 is a 2. All right, so hopefully we're able to use the unit circle that way. A little bit more right here. Cosine of 210. Hopefully you know that 210 is a little bit past 180, 30 degrees past that. So what did I have to do to get to there? Over a lot, left root 3 over 2, down a little, left a half. I'm sorry, down a half. So cosine says it's the x value. It's technically x over r, but again, r value is always 1 with unit circle angles. So I'm going to flip the negative 1/2 and get a negative 2. Oh, dang it. Sorry. My bad. Right here, cosine is the x value. I'm going to flip the x value, which gives me negative 2 over root 3. And then I'm going to rationalize by multiply by root 3 over root 3 and get negative 2 root 3 over 3. All right? So far, so good? Okay. So anyway, back to tangent of 120. So tangent of 120, hopefully you're thinking about this. 90 straight up, 120 is just a little bit past that. And right here, to get that, we know tangent's y over x. Well, what would the y movement be? Up a lot. Square root of 3 over 2. What would the x be? Left a little. Negative 1/2. What cancels on this? Since they're both in the denominator, I can cancel those, and I get a negative 1 over, a root 3 over a negative 1, which is a negative root 3. So hopefully you're seeing this stuff. And then finally, cosecant. The cosecant, 5 pi over 6. If you're having trouble with that, remember, where do you go one smaller than the bottom? That would be in the second quadrant. And do you remember how you label it? 2, 3, 4, 6, 2, 3, 4. So the one with the 6 in the bottom is the one that's closest to the 180 or the pi. So that's 5 pi over 6. Well, if the triangle looks like that, it looks like I moved left a lot and up a little. So if that's the case, what do I do with cosecant? Cosecant is a reciprocal of sine. Sine is the y value. So I'm going to take that y value and take the reciprocal of it, and I get 2. So hopefully you can navigate your way with the unit circle. If you had one sitting in front of you, you wouldn't even have to sketch out a little picture of it. You could just go find it. If you don't have one and you feel like the need to draw an entire unit circle out and label everything and then use it, great. But I'm just thinking how the unit circle works and sketching a real quick vision. Now, in my head, I know where they are, so I can do it in my head, but I've done it a couple years longer than you have. So if you need to do something like that, do it. If you've already got it burned in your brain, even better. All right? And then, so for page 2, starting with number 9, determine the angle in each quadrant which has a reference angle of 34. So here's what I'm saying here if you don't even know what I'm asking. And this kind of thinking is useful when we start solving stuff like 13 and 14 and 15, or really 13 and 14 and anything like these. But what I'm basically saying is if your reference angle was 34, what would the angle in each of these quadrants be that had that reference angle? So if you think about this, I'm just going to draw a picture of this in the middle. A reference angle is an angle made by the terminal side and the x-axis. Now, the terminal side, sorry, that's supposed to be the same as this one. Sorry about that. Okay, so here's an example of an angle. Pretend that's the initial side. I open to here, and the reference angle is 34. Well, if I open that much, what's the actual angle in the first quadrant? Well, it's 34. But what if that angle right there is 34, but I want to know what angle in the second quadrant opens up to be 34 degrees here? Well, that would be like 180 minus 34. That's what that big one would be. So in the second quadrant, 180 minus 34, 146. Okay, and hopefully I won't make any little careless errors on that, but I'm pretty sure we're at 146 there. All right, what about in the third quadrant? Well, in the third quadrant, I got to go all the way to 180 and then an extra 34. So to get from there all the way to here, that's 180 plus 34. That gets me at 214. And then finally in the fourth quadrant, technically I could just say negative 34. So because I didn't tell you it had to be positive, negative 34 is probably okay. But a lot of times they'll tell you that they always want the angle. They'll say something like, hey, make your angles bigger than 0 but smaller than 360. That way you don't get two different versions of answers. So if it's going to be positive or between 0 and 360, I got to go around this way. So what would I have to do to go all the way around to here? Well, if that little reference angle is 34, I got to go 360 and then subtract that off, and that would give me 326 degrees. So either of these are technically right in this case, but if you ever see a condition like that, you can't give me that one, you'd have to just give me this one. All right, now what about these two? This says which sine of the angle, which angles between 0 and 360 would make that true? Well, you can go to your unit circle for that. And you can think, all right, what is sine? That's a unit circle value. You should recognize that and that from the unit circle. All right, that looks, sine is a y value, right? Whereas cosine is an x value. So if sine is a y value or y coordinate on your unit circle, where do I go down a lot? So think about, if you're looking at unit circle, you can see it. But if this is a makeshift unit circle. Where do I go down a lot? Well, I go down a lot when I went over a little. And I can go over a little and down a lot, or over a little and down a lot. And what would those two be? Well, it looks like that's a little 30-degree this way and this way. And if that's 270, then these must be 240 and 300. Okay? Because remember, this is 180, and then it goes to 210, then it goes to 240, and in the middle there's a 225. So it looks like the angle in between there that would still make that true, there would be two of them. 240 degrees, 300 degrees. And I don't want to put plus 360n on there, because if I start adding 360s or subtract 360s, then they're no longer in between here and here. All right? So what about this one? This one says, where is cosine a half? Well, cosine a half means I've moved to the right, not down, because sine is y. Cosine is x. So where is your x positive a half? Okay, so I think, well, if I had a unit circle right here, x is this way, right or left, but where do you go positive a half? I would be right a little. Well, where do I go right a little? Well, I go right a little and up a lot, or right a little and down a lot. What would those angles have been? Well, it looks like that would be a 60 degree here, and this would be a negative 60. And a negative 60 is the same thing as 300. Now again, if you're saying to yourself, why can't I just put negative 60? Well, you normally could, except, well, I don't know about normally, but it would be right if I didn't say that. Negative 60 is not in between those two. 0 to 360 means it has to be positive. Greater than 0, smaller than that. Negative 60 is to the left of 0. All right, so it's all about that condition that made me not use negative 60. All right, now these are a little trickier, because eventually you'll have these memorized, and I probably would have had you memorize them this year, but I like doing it in class, and it's a little harder to show you this, but we know that tangent of an angle is the y over the x. So this is a little trickier, and hopefully after a while you'll start noticing how to do these a little more easily with tangent. But the y and the x values don't look like root 3 over 3. So what you have to do is think, well, which y values and which x values of each of these coordinates, of each of these angles, would end up simplifying to this? Well, let me show you a couple that wouldn't work. Like, what if I said, all right, what about when y is square root of 3 over 2 and x is a half? Well, that's not going to work, because look, the 2's cancel and I get root 3. And it's not going to be root 2 over 2, because that always goes with root 2 over 2. If I put y over x like that, everything cancels and I end up getting 1. Okay? But look what happens if you put a 1/2 over a square root of 3 over 2. Those go together, and if you put that over that, the 2's cancel. I get 1 over root 3, which when I rationalize becomes root 3 over regular 3. So where would it be negative? That's what makes it trickier. Well, first you got to look at it and go, well, which values or which coordinates on the unit circle have that as a y and that as an x, right? Because that's what tangent is. So y would mean up a half. Well, where do I go? Square root of 3 over 2, that would be right a lot, and up. And actually, one of these has to be negative. So where do I go? Right a lot, or right a lot and down a little, or maybe left a lot and up a little? Well, let's think about that. This is why it's a little tricky when you don't have the unit circle. All right, burned into your brain. I could go right a lot and down a little, right? That's over square root of 3 over 2, down a half. That would be y over x. That would make sense. Or I could go left a lot, up a little. That would be left square root of 3 over 2, up a half. All right, and that would be that angle. So that looks like a pretty small 30-degree little triangle there. So what would that be? Well, all the way to there is 180. Back 30 would be 150. So my angle would be 150. That's one option. Or also, this looks like a 30-degree reference angle, and it's not all the way to 360. It would be 330. So 150 and 330 would both work, and you got to use positive values between 0 and 360. This last one's a little trickier here on 11b. It says cosecant. I really don't like thinking about cosecant. So I know that cosecant is the same thing as 1 over a sine because they're reciprocals. Okay, so if I change cosecant to 1 over sine, right, and just drop down the -2, then I could flip both sides. And if I flip this side, I get a regular sine, and if I flip that, I get a -1/2. So I'm back to ask myself, where would sine be a -1/2? And that's just going back to unit circle. We know that sine uses the y coordinate. So where do you have y coordinates that are down a little? Well, I could go down a little there, down a little there. Well, which would those angles be? Where do you go left a lot, down a little? Well, that looks like 210. Where do you go right a lot, down a little? Well, that looks like 330. So 330 and 210 would be the thetas that make that true. All right, now on to 12A and 12B. This is just more calculator work. So I'm going to zoom in again so you can see this on the calculator. All right, remember, you're gonna probably live most of your time here in degrees. So I would probably encourage you just to leave it in degree if you have an Inspire, and then when you need to do a radian, put that little R on there, and I'll show you that if we run into one of those. So here, trig, go over to tangent, type in 224, it's already in degree mode, hit enter, 0.966 if you're rounding to 3 decimal places. And when I say 3 decimal places, I mean 3 places to the right of the decimal. All right, now this is also a degree, but on this calculator, I do have a secant button. You don't on scientific, so I'll show you both ways. Here, trig, over to secant, type in your 312, and you are 1.494 and done. 1.494. Now, if you have a scientific calculator, obviously it's pretty similar with tangent. All right, with tangent, you're just gonna go tan 224, make sure it says deg down there at the bottom, and there's your 0.966. But for secant, it's a little trickier because I don't have a secant button. And you can't use, guys, you cannot use inverse cosine for secant. I know the -1, it makes you think that it means 1 over cosine. It doesn't. This is what you do when you're trying to solve for an angle, not when you know the angle and you're trying to find the actual ratio or the value. All right, so what do we do? Well, without a calculator, you got to change secant theta to 1 over cosine theta. So secant theta, 1 over cosine theta. So secant 312, 1 over cosine 312. Don't flip the angle, flip the trig function. And then you just type that in. All right, so I'm going to go 1 divided by the cosine of 312. And that's going to give me what, 1.494. All right? So hopefully you're in good shape on both those. Now, hardest part of this test every year, some people go, how is this hard? It's not hard at all. Well, if you've done all your work, you probably won't think so. But if you haven't, you're gonna make some mistakes. Now, one thing I've done differently here, and it really is gonna make your life easy, notice what I gave you here. On all of our homework, I just said solve for theta, and you kept having to put that plus 360 in. But if I only tell you to give me the angles between 0 and 360, what would happen if you add 360 to an angle like that? Well, it becomes bigger than 360 and therefore no longer true. So on these, you really don't have to put the plus 360 in on there, which is kind of nice. So I'm trying to make your life a little easier. So what do you do here? I got to inverse cosine both sides. But if I inverse cosine both sides, it cancels here. And it leaves me inverse cosine of the right side over here. Now, what did we say to do in class? Hopefully you remember that I told you to make this positive. And when I do that, it guarantees that my calculator will give me a reference angle. If you don't do this, especially on this problem, your calculator is not going to give you a reference angle. And then you got to go find it. And then you have to have the reference angle to find the other angle that works. So why not just find it from the very start? It makes your life easier more times than not. So I'm going to go here. I'm going to go, all right, trig. I'm going to do inverse cosine. All right. So I'm typing in inverse cosine of positive 0.7892, and it spits out 37 point, and we're going to round to the 10th, so 37.9. So my reference angle is 37.9. Now, if I don't make that a negative, what you're going to end up with here is something like, what is it, 142.1, I believe. Let me double check that. If you don't, yeah, 142.1. And 142.1 is actually your first angle, which I don't know yet. I only know the reference angle. But then you're going to have to remember, oh yeah, 142.1. I've got to now find the reference angle from that. So you got to mark it in the second quadrant and think, all right, what is the length of that angle to the x-axis? And that's where you get your 37.9. Well, why do all that work? Why not just make it positive, find the reference angle, and go, all right, where is cosine negative? Remember, all students take classes. Classes stands for cosine and secant. So cosine's positive, first and fourth quadrant. But this cosine's negative. So where must your reference angles be? In the second and the third. And if my reference angles are right there, then what are the actual angles measured from 0? Well, if that's 37.9, then I got to go 180 minus that part. So my actual angle is 180 minus 37.9, which is 142.1. Now, in your homework, you wrote plus 360n, but because any adding or subtracting of 360 from this makes it too small or too big, I can stop. Now, the other angle is that one. This one, I got to go 180 plus the reference angle. So 180 plus that gives me 217.9. And again, I don't need plus 360n because it would be too big or too small, so I can stop right here. All right, now, this problem for number 14 is exactly the same as number 13 if you have an Inspire. So if you have an Inspire, you should get the same results as I'm going to get if I use a TI scientific calculator. So I'm going to work it with the scientific, but just know if you had an Inspire, just write reference angle equals inverse cosecant. And when you do the inverse cosecant right there, it'll spit out a reference angle of 10.9 degrees. Go mark that 10.9. That's all you have to do. But if you don't have an Inspire, you can't do inverse cosecant. So what you have to do is kind of like you did up here in problem number 12 without an Inspire, you got to get rid of cosecant. Well, cosecant is the reciprocal of sine. So I'm going to change it into a 1 over sine. And then just drop down the 5.2953. Now I can flip both sides. So the sine of theta, and rather than writing 1 over 5.2953, which I know I just wrote, why don't you just write out what that's equal to? So I'm going to take my calculator and type in, all right, 1 divided by 5.2953, and that spits out 0.1888, blah, blah, blah. So I'm going to write down 0.188846, and this is now what I'm trying to solve. Now, you don't have to do that step. So what do I do here? I'm going to find the reference angle by doing the inverse sine of all this. Now, what you would have done with an Inspire, blah, 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 and try to be exact as possible. With an Inspire, you wouldn't have had to do this. You would have just written the reference angle is inverse cosecant of 5.2953. And your actual reference angle you get is going to be the same reference angle I'm going to get here. So I'm now going to go inverse sine, second sine, second answer. Pull up what I just did. If I have a TI Inspire and I hit enter and it spits out 10.9 degrees, but you would have gotten that on the Inspire much more quickly with a lot less work. So it's still not too late to get an Inspire, especially if you plan on taking our class again next year. I work with Inspires, and the 84s I don't teach from, although they're okay. And it's a good calculator. I like it. In fact, sometimes it's better for me, but the Inspire as a whole, I think, is a little more, makes a little bit more sense. It's a little bit more like normal technology today. So where does this angle show up? Well, if you think about it, this angle could, reference angles could be anywhere, but where is cosecant positive? Well, remember, all students and sine and cosecant, right? They're the ones that show up here in that quadrant. That's where they're positive. Well, this is positive. So I'm going to draw the reference angles here. and I'm going to find that angle, and I'm going to find that angle. Well, that angle's easy. It's what I got, 10.9. So my first theta is 10.9. And again, don't have to add the 360 in because it's only between 0 and 360. And my second angle, or you could put them in brackets and just list them. My second angle is 180 minus that 10.9 for 169.1. And try not to forget the degree signs on there as well. All right, and then lastly, I hope we got a little bit more past. We have a third page too, don't we? Ooh, it's gonna be long. Hopefully, you've done all this in your head, and you're just looking at the ones you need. On 15, all right, it says find the missing side or angle. Assume a right angle where A plus B is 90. So again, this is just me way of saying, all right, we know that if I give you this stuff, we're gonna assume that C is the 90 degree. And that if this is A, angle A, then that's side A. So that would be 3. And if this is angle B, then this is side B. So that must be 5. So based on this, it looks like I need to find angle A, angle B, and side C. All right, so what's the first thing I can do on this? Well, actually, I don't have to find all that. It just says find angle B, even better. All right, so how do I find angle B only given these two sides and that angle? Well, sounds to me like a little trig is in order. All right, I don't need to find all this other stuff. So according to this angle, this would be the opposite side and the adjacent. Opposite and adjacent would be tangent or cotangent. I like tangent. So I'm going to do the tangent of the B. All right, so tangent of angle B would be opposite over adjacent, so 5/3. And now it just becomes a problem like 13 and 14, except we know tangent is acute. So I don't have to find that other angle like I did on 14 and 13 that was not acute. So I'm just gonna go find the acute angle here by doing the inverse tangent of both sides. So inverse tangent of 5/3, I'm gonna write that here, but you probably don't need to do that. If I do the inverse tangent of that 5/3, I get 59.0. So angle B is 59.0. And here, we don't have to draw a picture, right? We don't have to say, hey, tangent's positive right here. That means it must have a reference angle here and here. I don't have to do that because it's an acute angle. There's no way it can be like bigger than 180 degrees. This is not necessary like it was up here, okay? I know it's acute because we just said that the C was 90 and A and B is 90. It's got to be here. It's got to be a triangle here in the first quadrant based on C is 90. All right, so done with that one. And then on this other one, I'm going to think about the picture as well. So back to A, B, C here. C is 90. And it says B is 5. Let's make this B just for fun. If that's B right there and that's 5 degrees, then this would be A. And it says also A is 7. I do not know B and I do not know C, but it says find C. Well, I know this angle and I know this and I want this. So how can I put that, and that together? Well, from this angle, this sounds like an adjacent and a hypotenuse. That sounds to me like a cosine. So why not cosine of B, which is 5 degrees, set that equal to adjacent over C. So that's what I would do. And then how do I solve for C? Well, if you remember the slide rule, you could slide the C up and the cosine of 5 down. And that would leave you this. And you could just type that in your calculator, and that will spit out 7.03 if I was rounding to the hundredths. Okay, sorry, 7.03. Or you can cross multiply. If I cross multiply, I get C times cosine of 5 equals 7 times 1. And then you could just divide away the cosine of 5. And again, it gives you the same thing. So depending on how you want to think about it, you should get 7.03 there. All right, back to 17, A, B, and C. A little bit more practice with the unit circle. I'm going to try to move a little faster there. Sine of 330. 330 is way over here. It's down a half, so negative 1/2. All right, secant of 135. 135 is right in the middle of here. Secant is the reciprocal of x. X and y are the same. It's left root 2 over 2 over 2. Root 2 over 2. So flip that. So that becomes a negative 2 over root 2, which when you rationalize, this becomes 2 and cancels with that, and you get a negative root 2. And then finally, 7 pi over 4. 7 pi over 4 is over here. Tangent there means put the y over the x. Well, those are the same. If I put y over x, this is positive, that's negative. If I put y over x right there, I end up getting a -1. And you can take more or less time depending on how comfortable you are with the unit circle there. All right, number 18. It says, don't forget to review angle of depression and elevation word problems. We just did some problems on that. Make sure you check those out. Ask me questions if you have issues. I'm going to jump to number 19. It says round answers to 3 decimals. This is giving you some practice on using radians. Okay, so if you have an Inspire, I'm going to leave it in degree mode because I have that ability to do that. And I'm going to type in trig over there to cosine. And I like the fraction button, so I'm going to do control division. That gives me a fraction button. And I'm going to type in 2, and then I'm going to go down to the bottom left, hit the pi button, choose pi, go down, enter a 5. And then remember what we do? We go to the right of the fraction, but not outside the fraction, just to the right of it. And then I go pi button, and I'm going to choose radians. And if I do that, that tells me it's a radian. Now, those of you with newer Inspires, I think you guys were showing me you could click on the degree and it just changes it to radian. Awesome. But if it's an older Inspire, maybe you borrowed it from a brother or sister or you got handed me down, this always works as well. And it should spit out 0.309 for you. All right, so 0.309. All right, and then cosecant, again with an Inspire. This is not so bad because I have a cosecant button. So I'm going to go trig, but I'll show you how to do it if you don't. Cosecant is right there. So cosecant, make a fraction, 15, choose the pi over the 7, go outside of the fraction, but not outside the parentheses. Go back to pi, choose the R button, and hit enter, and you get 2.305. If you're rounding to 3 decimals, which it asked you to do, so 2.305. Now, if you do not have an Inspire, how do you do this? Well, cosecant's not on my calculator, so I've got to flip it. Cosecant of an angle. I know that looks like a fraction and you're tempted to flip that fraction. Don't. This is an angle. I don't know what it is. It's actually a little bit more than 14 pi over 7, which is 2 pi, so it's probably a really small angle in the first quadrant once you rotate around, but doesn't matter. Cosecant of theta is 1 over the sine of theta. Cosecant of 5 pi over 7 is 1 over the sine of 15 pi over 7 is 1 over the sine of 15 pi over 7. Don't flip the angle. Flip the trig function. Okay? So I would have to type that in. So I would go to my calculator, right? And I would type in 1, all right, divided by, let's get this on the screen for you. 1 divided by sine, and then just go 15 pi divided by 7, right? Make sure you change this to radians before you hit it, and then hit enter, and there's your 2.305. All right, same thing I got before, 2.305. So make sure you're changing stuff from radians to degrees, or you're going to miss stuff. All right, a quick review of the 30, 60, 90. Remember, if it's a 30 there and a 60 there, short side is 1. You're welcome to put 1a. Long side is double that, or 2a. Short side is root 3 of whatever that is. And if you need to write 1a or 2a or a root 3 to show the proportions, that's fine. But I'll accept 1, 2, root 3. And then here, 45, 90s, these sides match length. So these angles must be 45s, of course. So we can call those anything we want, but we normally go 1, 1, root 2. Now, if you want to label this square root of 3 over 2, 1/2, 1, or square root of 2 over 2, square root of 2 over 2, 1, you can use the unit circle proportions if you want, but these are a little bit more basic. All right? All right, this goes back to 22 goes back to one of the first problems we did. It says, hey, if this was an angle that had that value, all right, what are the other 6 trig functions? So I want to know, what is the sine? What is the cosine? I already know tangent. What is the cotangent? What is the secant? And what is the cosecant of the angle that would do this? Well, good night. I don't even know where this angle is. I know it's negative. And it also says that sine of this very same angle is also negative. Well, where would sine be negative and tangent be negative? Let's think about it. All of them are positive here, so it's definitely not in that quadrant. Here, sine is positive. According to this, sine of the angle is negative, so it can't be here. Here, tangent's positive, right? So it can't be there. But here, the only thing that's positive is cosine and secant. So sine and tangent would be negative. And according to this, they're both negative, right? Negative, less than 0 means negative. So this angle must be somewhere in the fourth quadrant like that. So there's your theta. Well, draw a picture with that. If that's your theta, then here's your triangle. And according to this, the tangent of that angle is opposite over hypotenuse, over adjacent. So opposite 2 over adjacent 3. And which one do you think has the negative if 2 is down? The 2. So based on that, could you figure out the hypotenuse? Yeah, pull out your Pythagorean theorem. That squared plus that squared equals that squared. If you do the math on that, you end up getting root 13. So now do your trig functions. What's the sine of this angle? Opposite hypotenuse. Negative 2 over root 13. Rationalize. Sorry, a little sloppy. What's the cosine of that angle? Adjacent over hypotenuse. 3 over root 13. Rationalize. What's the cotangent? X over y. 3 over negative 2, or negative 3 halves. Hopefully we could have gotten that by knowing it's just a reciprocal of tangent. What's the secant? Well, it's the reciprocal of the cosine. So root 13 over 3. And what's the cosecant? It's the reciprocal of sine. Root 13 over negative 2. And we don't like putting that negative 2 on the bottom, so we put the negative out to the side. So those are your other 6 trig functions. Other 5, we already knew the first one. And then cosecant, man, I hate dealing with cosecant like that. A lot of times you can if you want. You know that cosecant's a reciprocal of sine. Sine is opposite over hypotenuse, so this must be hypotenuse, and that must be opposite. So you could do this way, but a lot of times, I know a lot of people that just change it to a sine, flip that and flip that, flip them both. Right? You're allowed to flip both. So flip that, change it, it becomes a 1 over sine, but flip it becomes a sine. So flip them both, and then just do the problem just like you did before. So where is sine negative, cotangent positive? Well, they're all positive here. And this one's positive and this one's negative, so it can't be there. Here, tangent's positive along with cotangent. And it says here, cotangent's positive. Well, sine's going to be, I'm sorry, all students. Good night, what's wrong with me? This sine and cosecant are positive here. According to this, sine's negative. So no. Here, tangent and cotangent are positive. And sine would be negative because sine's only positive there and there. So this must be it. This is the only place where cotangent would have a positive value, sine would have a negative value. Well, make your triangle. I'm going to make that look a little prettier. So if it's down here, right, and there's your angle, technically that's your angle, but we're thinking about it like this, then what would negative 5/3? Well, cosecant is hypotenuse 5 opposite 3, right? Which one do you think's negative? Well, it can't be the hypotenuse. And these are both negative, but I don't know that. But I could do a little Pythagorean theorem and find out that this is the 3, 4, 5 triangle. All right, or I could do x squared plus 9 equals 25, right? There's the 9 equals the 25, and then solve, right? And get plus or minus 4, but we know that it's the minus 4 if I'm going left. And then now that I know all this, well, there's your sine. Cosine would be the adjacent, negative 4 over 5. Tangent is going to be the opposite over adjacent, so 3/4. Negatives get canceled. Cotangent is the reciprocal of tangent, so 4/3. Secant is cotangent theta. Secant of theta is the reciprocal of cosine, so negative 5/4. And cosecant is the reciprocal of sine, so negative 5/3, but we already knew that. All right. And then this last thing, these were on the homework problems. A lot of you might have freaked out a little bit. It says, rewrite the following trig expressions as a trig function of an acute angle. So these aren't that bad, but this is my thinking on this. All right, so right now, here we got a 336-degree angle, which is somewhere right there. Okay? Well, do you remember how there's a whole bunch of angles when you take the tangent of them, you'll get the same answer? Okay? Well, according to this, when I take the tangent of 336, you could do it in your calculator. You're going to get some value that's I don't know, it's negative because it's over in the fourth quadrant. It's probably something like negative 0.3 or negative 0.4. Let's go ahead and just do it. You're not going to have to do this problem. So here's tangent of 336 and negative 0.4, okay, ish. So there's a bunch of other angles like 336 that would also give you a negative 4. Like for instance, the reference angle. Okay, now it says an acute angle. The reference angle here would be 24 degrees. Well, if I do tangent of 24, do it in your calculator, try it. Trig, tangent of 24, I'm going to get a positive 0.4. Same value, but positive. But this one gave me a negative 0.445. This one gives me a positive 0.445. So are they equal? No, but how could I make them equal? Make that negative. Now, some of you go, well, could I make the left side negative? Well, I was asking you to rewrite this as a trig function of an acute angle. So now this is a trig function of an acute angle, but to make it true, I got to negate it. Now, you may go, well, how do I do that without a calculator? Well, probably won't have that question on your test, because with a test you might be able to, but bottom line is I know that a tangent of an angle over here, remember all students take tangent's positive here, it's negative there. So I knew that that was going to give me a negative value. So just think to yourself, negative value. And if I use the reference angle, 24 degrees is over here technically. I know that's going to give me a positive value. All right, well, how do I make a negative value equal a positive value? Well, I'm going to have to negate that positive value, and that's why I negate it. So let's try it on this one. Cosine of 279. Now, where's 279 show up? There's 270, so 279 is like over here. So what's the reference angle there of 279? It's not 9, right? It's 81. 360 minus that 279 gives me that 81. So the reference angle is 81. So is cosine of 279 the same thing as cosine of 81? Yeah, because cosine in that quadrant is positive. All students take classes, cosine. And 81, cosine of positive 81 is also positive. So since these both give me positive values, I don't have to change it like I did on number 24A. I'm done. Last one, sine of 185. Where would that be? A little bit past 180. All right, so that's 185. What would the reference angle be? 5. So let's start with this. Now think about it. Sine of 185, would it be positive or negative? Sine, all students, it's positive here. So it'd be negative there. But what's sine of 5 degrees? That would be a positive. How do you make these match? Make that one a negative of the positive, which makes it a negative. All right, and then very lastly, 25 and 26. These were also homework problems, first couple days. It says determine the values of the trig functions of an angle in standard position that goes through that point. So let's just sketch that really quickly. Negative 4 up 7. Okay, so if it went through negative 4, oh, sorry, dang. Negative 4 down 7. So if it goes through negative 4, negative 7, it would make that triangle, which makes that negative 4 and that negative 7. Well, could you figure out this missing side if that's the case? Yeah, you could pull out the Pythagorean theorem, and that squared plus that squared gives me, what, 65, and then square root 65. So those are my sides. Well, can I find the values of all the trig functions? What's the sine of that angle? It's always got to be this angle, never that one. All right, when you're sketching it on an x and y, you're always measuring from 0. So that angle, sine, opposite hypotenuse, make sure you rationalize that. So negative 7 root 65 over a 65. All right, what's the cosine of that? Negative 4 over the root 65. Sorry, blah, yada, yada, yada. Okay, what's the tangent of this? Opposite over adjacent, 7/4. And then for cotangent, what do? We flip the tangent. For secant, what do? We flip the cosine, which I'm going to flip that version, not the simplified version, and get root 65 over 4, negative 4, and bring the negative out to the side of the top. And then finally, what's the, dang, you can't see any of this. Sorry. The cosine would be the adjacent over the hypotenuse, and then I would simplify it. Tangent is opposite over adjacent. Cotangent, flip the tangent, adjacent over opposite. Secant, I'm going to go and flip the cosine, root 65 over negative 4, but put the negative out to the side or on the top. And then the cosecant of the angle. Make sure you're always writing cosecant of angle, secant of angle, tangent of angle, etc. Cosecant of the angle, I'm going to just flip the sign and get root 65 over negative 7. But again, put the negative out to the side or on the top. All right? Then 26 says, make sure you know your word definitions. We went over that first day. That first day would be before coronavirus took over the country. We went over that. You have some notes on that. They're also in your book somewhere. And I think you're going to be in good shape if you did well on this. If not, maybe review the problems you didn't know how to do. You know, my tests are usually pretty similar to my review sheets. All right, guys, good luck and take care of yourselves.